Why do some cats and dogs have patches of different colors? Well, it's because of a process known as X chromosome inactivation, where one X chromosome is inactivated. Think of two group chats pinging non-stop on the same phone at the same time. At first, it seems like extra updates, but soon the phone just overloads and crashes. That's exactly what happens in the human body. Males have one X chromosome while females have both. If both stayed active, the cell would run from an overdose of gene expression, so one X chromosome mutes itself. This process is called X chromosome inactivation. Here's how it works. On the X chromosome chosen for silencing, a gene called exist switches on. Think of exist as the manager of a shutdown crew. It produces a long mRNA molecule that spreads across the chromosome, like rolling out of a giant blanket that covers every corner. Once the blanket is in place, proteins arrive to secure the shutdown. Some modify histones that spool that DNA wrapped around, flipping them from active to inactive. Others attach methyl groups like bold to not open stickers on the DNA. Layer by layer, the chromosome is locked down until it finally curls down into a dense wall known as a bar body. At this stage, it's like a book that's been padlocked in a shelf and can't be opened ever and forever. Now, let me pick an X chromosome to inactivate. Oops, wrong card. Wrong card again. In some cells, the maternal X switches off, in the other, the paternal. This randomness creates a pattern known as mosaicism. That's why calico cats have different fur patterns. Each patch represents which X chromosome is active. Well, it's more than just trivia. X chromosome inactivation helps us understand diseases like Rett syndrome, autoimmune diseases, fragile X, and even cancer. In some cases, having the faulty X switched off can even protect the individual. That's wild, right?